Hello and welcome back, everyone. This is Latitude and Longitude, Lesson 1, Section 3. We are in the tools of geography. So, we're going to get another tool in our pocket today, and that is going to be latitude and longitude. Let's get to the bell work. I could use coordinates to find a location on a map. All right, this is really, really important. It is a skill. We're going to be going through the notes and the vocabulary today, and then tomorrow we're going to do a little bit more hands-on when it comes to finding latitude and longitude. All right, so it's a kind of a 2-day project, but this is very important. So once you have the bell work at the top of your paper, I can use coordinates to find a location on a map. We will go ahead and get started. So let's start with latitude. Latitude is the lines that run east and west on a map or on a globe. We have this map here only shows the latitude lines because as they run across from west to east or east to west, however you want to say it. All right. So the way I remember latitude, that it's the flat lines, is I say flat latitude, flatitude. All right. Flat. It rhymes. That's how I know it runs across. That's the easiest way for me to remember, okay? So the parallel lines of latitudes are parallel to the equator. So the equator is the very, very center of the Earth, the line that cuts the Earth in half like a hamburger, all right, going across, okay? And then from anything above the line, any line that's uh, above the equator is labeled as north, right? It's north of the equator. And anything below it is south of the equator, okay? So labeled with south. So these grids help us find absolute location, tying back to 1.1. All right, so right now we only have one half of the grid. All right, we just have our latitude lines, but there is a second set of imaginary lines that we'll get to here in a second. The equator is the latitude line that is halfway between the north and the south poles. Okay, so it's the equator is halfway up to the North Pole, halfway up to the South Pole. It's just directly in the middle. All right, so we're gonna make our keyword. Let's see what parallels. Parallels is going to be our key word. As I'm circling the word parallels, our keyword. As each line of latitude is parallel to the other, meaning they will never touch. They are going straight in the same direction. That is a mathematical term, but we do use it here in geography a little bit. All right, so parallel lines running across the map. Okay, so we're going to put this all together. It is a lot of information. Again, this takes more than one day, but once you get used to it, it is fairly simple, and then you become a pro at locating locations on a map. How about that? All right, so again, the equator this is a map of the entire Earth, right? But it's on a flat surface, so it is distorted a little bit. But now we have the equator line labeled in blue, all right, cutting across the middle, all right? And these other lines right here are parallels, right? They are parallels up north and then parallels to the south. All right, so the equator is again the line that cuts right across the middle, and parallel lines are measured in degrees. Okay, so it's interesting. I know degrees, like you think, okay, temperature is measured in degrees. Well, angles are measured in degrees as well. And in this instance, our latitude and longitude lines are measured in degrees. So the equator is 0 degrees because that is the middle point. That is the halfway point. So it is just measured is 0. All right. But anything above north, the number goes up. Anything south, the number goes down, right? So it's like south, you could almost think about it as like -10, -20, -30. And then up north, it's +10, +20, +30, whatever works for you in your head. But the equator, that is what you have to remember. This is the most important thing. The equator is 0 degrees latitude. All right. So if you ever need to know the middle point, you just point to the equator, that is 0. And all the other parallels, all the other lines that are moving up and down are based off of the equator. Everything is measured against the equator. And if they're closer to the equator you are, all right, the closer to the equator you are, the warmer it is. So these places in between the 10 north and 10 south are your warmest climates in the world, in planet Earth. And the coldest climates are going to be the furthest away points, places that are 70, 80 degrees south, again, 70 to 80 degrees north. These are your coldest points in planet Earth. Oh, did I give you a keyword here? Oh, I'm sorry. The keyword we're going to go with is climates. Climates is going to be our keyword. Keyword is climates. All right, the warm climates are near the equator. Climates is our keyword. All right, so draw a line across that 60 degrees north latitude. So if you were doing this, again, the equator is 0 going across. And when we're saying north, we're going to think of positive, right? Because it is up. It's counting upwards. So the north, see, it says north labeled up here, south labeled down here. 60 degrees north would actually be up on this line right here. Okay, right line going across. Latitude, latitude. All right, so far, just talking about latitude lines. All right, we're breaking this down in half. We talked about latitude and it'd be measuring by degrees, right? And latitude lines run east and west. They are flat on a map. All right, now we're going to talk about the meridians of longitude. Meridians of longitude run north to south. They're going to be the up and down lines, the long lines, longitude, long lines running north to south. The longitude lines, although they are, although they are spread out, looks like equally, but they are not. They actually are not parallel. They do have a little bit of a curvature to it, and they will meet at the point at the very top of the Earth, right? So the distance between each longitude line does actually vary. All right, so we still use degrees to count it as we go all the way around, but again, they are not parallels. They're meridians of longitude. So we use a different word here, meridians of longitude, moving up and down. The prime meridian is kind of like the equator, but for longitude. The prime meridian marks 0 degrees longitude, and it actually does cut through a major city, Greenwich, England. And that's like up here, all the way up north. All right, so it's a high latitude line, right? It's pretty high up north latitude, but the longitude line, it sits exactly at 0 degrees longitude, splitting this north and south pole in half, like a hot dog. All right, so here we have latitude and longitude. Now we need to combine them. Now we need to see them together. All right, so we're going to make varies our keyword. Varies is going to be our keyword because the distance between meridians of longitude do vary. They are not parallel. Okay, so there is a big difference there. All right, places stars amongst the most important lines of longitude, the prime meridian. Okay, this map makes it fairly easy. Just to get it, now that we have all the latitude and longitude lines, we have the equator running east to west, the prime meridian running north to south here. See, kind of dividing the Earth into 4 quadrants, and we'll get into the quadrants here in just a second. All right, so another example of a map of the United States, or the entire world, I should say, the entire planet Earth. And we're going to use this a little bit to now use our latitude and longitude and apply our knowledge. So if you're looking at a map of the entire Earth, it's hard to find just a spot, right? Let's see, like city B, okay? City B, it's like, how would you find that? How would you describe that without latitude and longitude? Latitude and longitude make it very, very simple to find city B on a map. And that actually is that Greenwich, England spot because it lies directly on the prime meridian, right? So finding a location does become a lot easier for geographers and for regular everyday people. Using latitude and longitude numbers are called, that should say coordinates, not ordinates. I'll have to fix that. Coordinates. A coordinate is using 2 numbers, right? Using 2 numbers, a number of latitude and a number from longitude, 2 degrees, sets of degrees, to find a precise location. So latitude ranges from 0 to 90 degrees north and 90 degrees south. 90 is the highest it goes. However, when it comes to longitude lines, it actually goes all the way up to 180, and that is going to be measured in east and west. It goes all the way from 0 to 180. The Earth is a little bit, has more width than it does length, if you will. All right, so just keep that in mind here, okay? So we're going to make location a keyword. Location is going to be our keyword, as these numbering grids help geographers find a location become easier, okay? So location is our key word. All right, so now we're looking for 30 degrees latitude line north, right? North is super important because there is 30 degrees listed on this map, and there's actually 30 degrees longitude as well, although not labeled. It is on there. So north, make sure we start at the equator. We're going north or up 30 degrees. And here we go. The red line would go across this line of latitude. Okay. All right, so now we're moving on to 60 degrees south. 60 degrees south, again, we are going downwards from the equator. We're looking for a latitude line, right? A latitude, not 30, but 60 degrees south. It would be this line that I am highlighting right now. All right, and then here we talk a little bit about combining these two things as the grid. Latitude and longitude form a grid system. Okay, the equator being the number one spot for latitude, the 0 degrees, and prime meridian being the main line for longitude at 0 degrees, 0 degrees longitude. This grid helps map locations accurately. Okay, so we can find exactly what we're looking for. And latitude lines are labeled north and south. Longitude lines, again, east and west. And geographic coordinates pinpoint these exact locations. We cannot emphasize these points enough because they are easy to get confused, right? Latitude, longitude kind of sounds similarly to each other, but it all comes down to accuracy. And so let's make accurately our keyword. Accurately is going to be our keyword. Accurately, these grid lines, these grid systems really help us hone in our exact locations. All right, so now we have degrees east, longitude line blue. So we're talking east and west now. We're talking longitude. All right, so our longitude prime meridian number is 0 going up and down right here. All right, and we are going east. So east is going to be our plus. If you see that number right here and it's labeled east, west is going to be going leftward. So we're going 90 degrees east of the prime meridian. This line going up and down, the longitude line would be our exact spot. And now here it says 180 degrees west longitude, line blue. All right, west longitude. So now we're going west from the 0 degrees longitude. So we're going to go all the way out to west, going up and down this line right here, the very edge of our map. Okay. So coordinates can be a positive number or a negative number, as we just talked about, if you're using that methodology for it. And degrees, minutes, and seconds are also measure coordinates as well. So these coordinates, these GPS systems, they do actually impact local time, and we'll get to that here in a second. When you're going through a time zone, as if you look at the map at the top right corner here, we have several different time zones in the United States. So if you're in New York City, labeled with NY, and you are in California, those are actually 1, 2, 3, 4 different separate time zones, right? In between. So it's going to be a 3-hour time difference from California to New York because of the position of the sun. All right, the Earth has a curvature to it, so the sun doesn't get to New York at the same time as it gets to California. All right, so this is going to cause a difference in when the sun rises, therefore a difference in the time. So that means latitude helps us determine the position of the sun, and then longitude determines the local time at a specific place. All right, in modern times now we have GPS systems that use latitude and longitude to help us out, making it a little bit easier for geographers, but it is good to know the root of what they're talking about, right? All right, so we're gonna make our keyword here position. Position is gonna be our keyword. Position, our keyword for our GPS slide. Position, our keyword. All right, and we will get to this tomorrow, actually, finding our exact pinpoints on the map. We'll get to that practice. For now, we are all set. Like and subscribe. That is 1.3 and latitude and longitude. So long, everybody.